In college algebra, we started working on other types of equations. The textbook calls them other types. But to be honest, it's all very familiar. Hopefully, this math that we're about to do or procedures are very similar to what we've talked about before. Nothing really new here. We want to start by factoring because that's the easiest way to solve these two. To be honest, I can't think of another way to solve. Well, there's a harder way, a very tedious way we're going to learn way down the road. But factoring is the way. You can't use quadratic formula on number 2. Number 1, you might be able to be creative and do it, but factoring is fastest. And when you factor, move everything to one side. So on number 1, I need to move that 27x squared over to the left side. So it becomes negative. And now we're ready to factor. Look for your GCF. 3 is the biggest number that divides into both of those. They both have an x, and go with the smallest exponent you see, which is a 2. Let's see, the leftover, I already took the 3 out, and there are still 2 x's in there. 27 divided by 3 is negative 9, and that x squared is gone. You can take this portion one step further by factoring it. Notice it's the difference of 2 squares. We've done that many times. Square root both. And we need a negative 9, so one must be plus, one must be minus. And then you're good to go. Make sure you solve it. All we've done so far is we've factored. So we know each factor equals 0. You don't necessarily have to write this step here. If you can do this step in your head, your final answer is 0, negative 3, and positive 3. All right, hopefully that one was easy and review. I hope number 2 is easy, but factoring by grouping is something that people struggle with. So I'd make a note next to this. If 4 terms, and that's what we have, try factoring by grouping. It doesn't always work, but I want to say it usually works, hence the word try. I need to also move everything to one side like I wrote at the beginning. So I need to move the 4x and the 4 to the left side, and we have something that looks like this. And we learned a few weeks ago that you group the first 2 and then group the last 2. So I'm looking at this group and this group. Take a GCF out of each group. So I can take an x squared out of that group, and I can take a negative 4 out of the second group. Now this is the weird step. I'm going to take an x plus 1 out of those 2 terms. So you write x plus 1 one time, and then write those previous GCFs in their own parenthesis. And you factored it. You can take this one a step further, because that's the difference of 2 squares again. Always keep your eye open for one of those. And then you're really done factoring. Now you just got to write the answer. And hopefully you can do that in your head. You set each one equal to 0. X ends up equaling negative 1. positive 2, and negative 2. All right, we're going to move on to this word problem. Galapagos Islands. So some statistician has created a model equation for this scenario. We're looking at S, number of species of plants, or just number of species. X is our area of the island. So in this problem, they want us to find X, the area, if we know S is 57. So just plug 57 into that equation up there, and let's solve for X. All right, the cube root, the check mark with the 3 in it, looks weird, but I do know for sure I need to get X by itself, so I need to get rid of 28.5. We're going to divide by it, and we get a nice number. We get 2. Now I need to make that cube root, that radical, that check mark, whatever you call it, to disappear. So if I cube both sides, it'll disappear, and we'll have just an X. If you have a more complicated number you have to cube, like maybe a big number, on your calculator, there's a power button. So you would press 2, and then here's the power button. It's in red on your screen. And then type a 3. If for some reason you want to undo that, press Control and then the power button. Notice right above it, it's microscopic, but it says the nth root. And you can change this root to anything you want. So like the cube root of 8. But hopefully everyone knows how to do 2 cubed. 2 times 2 times 2 is 8. So final answer, 8 square miles. All right, last problem. We have a square root with an x under it, and we have an x. We need to isolate the radical. In other words, move this x to the right side. So I want to rewrite this thing as square root of 26 minus 11x equals 4 minus x. I need that radical to disappear, so I can square both sides. And the radical will literally disappear. So now I have 26 minus 11x equals 4 minus x, 4 minus x. So you want to FOIL out the right side, and you end up getting 16 minus 8x plus x squared. Now I need to factor this, or I guess you could do quadratic formula because the highest exponent is a 2. Either way, I need to get everything on one side. So I'm going to move the 11x over, and I'm going to move the 26 over, and we're ready to factor. So I know 0 equals x squared plus 3x minus 10. And that one should be very easy to factor. X plus 5, x minus 2. X ends up equaling negative 5 and positive 2. Now, one thing I'm always unsure about or worried about is radicals and our answers. I typically am a little lazy, I'll be honest, and I don't plug things in. But if there's a radical, I always check my solutions. So I'm going to plug in a negative 5, and check it. Negative 5. Now, do as much mental math as you want. You don't even have to show this, but realize it's a risk. You might be wrong. So that equals 4. We have a 55 plus 26. So when we go 55 plus 26, we get 81, which is a 9, and that checks out. But when I plug in the 2, you would think plugging in the positive would work, right? Oh wait, I think it does work. Sorry. Made y'all nervous. I think it does check out. We get, so that's 22, so we get a 4, so we get a 2, and we do check out. It works. There's our answer. I think it was another problem I was working. Didn't work out. Anyways, see y'all later. Bye.